Hello students, welcome again in chapter 7 integration. Students, today I going ahead in the definite integrations exercise 7 question number 26. Integration 0 to pi by 4 sin x cos x below cos the 4 power sin the 4 power. Whenever the 4 power given, you always students will divide cos raised to 4 in numerator and denominator. Always if you 4 power given, then so what you get, if you divided, then you getting only your cos the 4. You also divide by sin raised to 4, that also correct statement, but cos is best because they converting indirectly 10, that much, and 0 to 45 as it is. Sure, it is cancel here 10, but that also cancel. So what you get here, 0 to pi by 4, 1 sin with cos means 10, other are sec square by 1 plus 10 the 4x. Now think about which derivative is this. Yes, you know that if I suppose, not if, suppose 10 square x is t, just like this one. So you getting the derivative here 2 tan x sec square x dx. Students, it is your 2 tan x, tan derivative sec square x dx dt. Sure, you have to tan x into sec square x dx is equal to dt by 2, and this you are applied by that fully total, but limit is changed. Limit is if x tends to 0, t tends to tan square 0, and tan 0 is if x tends to pi by 4, t tends to tan square pi by 4, and tan 45 is what? 1 square means 1. So my answer is I. 0 then 0, but 45 then 1. It is your dt by 2, and upon here 1 plus t square, because already I tan square x is t, so tan 4 is t square. Now your answer half, which have to tan inverse t. Limit 0 to 1 attach pi by 4 tan 0 0. My answer is only pi by 8. Now next question number 27. Integration. Similarly going ahead, 0 to pi by 2 cos square x dx below cos square x plus 4 sin square x. Students, whenever your data given sin square x, cos square x in denominator, then necessary you divide by cos square x. Again repeat, if you downwards given sin square either cos square, you necessary divide by your sin square either cos square. Either you convert in full in one variable cos square, either variable in sin square. I go to dividing, we divide numerator and denominator by cos square x, never 0. So what you get finally, if I divided by cos square, then 0 to 90. I explain you why I divided. It is 1, here 1, but that should be sin square by cos square x, and that you know tan square x. So students, my I 0 to pi by 2 1 dx 1 plus 4 tan square x. Now tan x suggestion, converting to limit change, that pi by 2 means infinity, and going to further solution, students. So assume tan x is t, derivative sec square x dx dt, but sec square x no present in this question, so I just write down 1 plus tan square x, and it should be 1 plus t square dx dt. So what is your dx? dt by 1 plus t square. This dx cover, but limit change. If x tends to 0, then t tends to tan 0. Tan 0 is 0. If x tends to pi by 2, t tends to tan pi by 2. But students, tan pi by 2 is what? Infinite. Yes. Now I go to slowly in my solutions. So I just put it my limits in the dt form. 0 then 0, pi by 2 then infinity. Dx I have dt by, and by downwards 1 plus 4t square. So you getting only dt by 1 plus t square and 1 plus 4t square, and here get 2 factors by partial fractions method. But I go to shortcut, don't worry students, I have shortcut method available. They have to taking 1 plus 4t square and here 1 plus t square. Anyhow I want to here 1 constant, so can I multiply that? Check. Here multiply and here 1. How much? 1 minus 4, 1 minus 4 minus 3 divided by 1/3, and 4t square minus 4t square cut, remaining your answer. You not going to partial fractions, it is very big method, this is a very shortcut. Now again check, 1 minus 4 minus 3, already minus 1 by 3 written I, and here 4t square minus 4t square cutting, so you have to this divided by this, 1 by 1 plus t square, and minus minus plus 4 by 3, this multiply, and that divide then 0 to infinity, 0 to infinity. Here what division? This and this cancel, only you have to 1 by 1 plus 4t square dt. Now simple, that is tan inverse t, integration 0 to infinity. Here just I write down one more steps for your easily formula dictate, 0 to infinity, 1 square b square. Yes, here apply our rule, upper minus lower, tan infinity pi by 2, tan 0 0, and here create your coefficient first, and constant square plus variable square, 1 by a tan inverse, students, x by a, limit again putting 0 to infinity, so that much cancel, 2 1s are 2 2s are, so my answer students minus pi by 6, here 2 by 3, and put it here 2 times of infinity, I mean tan inverse infinity, and here 0, so minus pi by 6, it should be pi by 2, and tan inverse 0 is a 0, this cancel. Yes, very easily you get it, your answer 6 minus pi plus 2 pi, it get pi by 6 answer, this main. But main important, I again repeat, if you sine square cos square in denominator given, 4 power given, then direct 4 is to divided, but if you square given, then you divided by square term, and easily get your students here answer. Continue. 28. So in the 28, integration pi by 6 to pi by 3 sine plus cos downwards under root of sine 2x dx. Yes. Here also very interesting question coming, students. First of all, think about which derivative is this? Yes, sine derivative for minus cos. So I suppose regarding to my numerator, I suppose sine derivative minus cos and cos derivative sine. So in that place I assumption minus cos plus sine is equal to t, and take the derivative differentiation with respect to x. So here sin x cos x dx dt. Students, your numerator done, but what is the denominator? Sin 2x. So I make here square on both sides. Necessary you do, otherwise you cannot derive in the value of sin 2x. I am making the square, cos square x minus 2 sin cos sin square x t square, and that how much? Sin 2x. And this what? 1. So my value is a 1 minus sin 2x, and that is your t square. So what kind of sin 2x value? Yes, 1 minus t square. That value I putting down there. Now limit change. So I start my limit. If x tends to pi by 6, t tends to, you assume already here, minus cos pi by 6 plus sin pi by 6. So cos 30 root 3 by 2, sin 30 half. In short, you getting 1 minus root 3 by 2. And next, if x tends to pi by 3, second order, then t tends to minus cos pi by 3 plus sin pi by 3. And attach their values. Yes, cos 60. So this cos 60 is your half, and sin 60 root 3 by 2. So root 3 minus 1 by 2. This is your new limits. And I start after that your t conversions in the limit wise, students, solutions. So major calculation done here, students. This limit changing, sin 2x apply there, it is dt, and limit applying, and you get the answer. So integration I, my limit pi by 6, 1 minus root 3 by 2. Second, root 3 minus 1 by 2. That dt, and upon under root. Sin 2x is also known. Over. Nothing there. So my answer is a sin inverse t, limit, you just successfully putting down there. Upper limit minus lower limit. Upper limit I have root 3 minus 1 by 2 minus 1 minus root 3 by 2. Can I here minus carry outside? They become same. So sin inverse root 3 minus 1 by 2 plus root 3 minus 1 by 2, and sure it is 2 times sin inverse root 3 minus 1 by 2, and that's your, students, easily and happily this question is done. Main step is this conversion by the making square. Yes. Now 29. Similarly, I going ahead slowly in this question, 29 number. Yes, it's very easy sum. Integration 0 to 1 dx by 1 plus x minus root x. Very simple. We just apply only and only conjugate terms. Yes. So what's your conjugate? 0 to 1 under root 1 plus x plus root x, that's under root 1 plus x minus root x. plus x plus root x. Sure, you have to hear a plus b, a minus b. So your data covered to 1 plus x raised to half, here also half, and that is your 1 plus x minus x dx cutting. Now integration. So students, my answer is easily 3 by 2 by 3 by 2. Limit at h 0 to 1. Similarly, x raised to 3 by 2 by 3 by 2. Limit at h 0 to 1. Now 2/3 outside. Attach your upper limit 1 plus 1 raised to 3 by 2 minus 1 plus 0 raised to 3 by 2. So that's upper limit 1, put it. Now 0 also put it because it's converted to 1. Similarly here students, 2/3 outside, 1 raised to 3 by 2 minus 0 raised to 3 by 2. So you have to 2/3, 2 raised to 3 by 2 minus 1. Same, 2 raised to 3 by 2, 1 minus 0. Now I think 2 raised to 3 by 2 students, I just common check and derive my answer. So your solution is a 2 by 3 as it is common. So what you get, 2 raised to 3 by 2 minus 1 and here plus 1. It should be cancelled. So 2 by 3 and 2 raised to 3 by 2 students, I write down 2 raised to 1 but 2 raised to half this one. So indirectly 4 root 2 by 3 is my final answer. Now question 30. Similarly going ahead slowly 30 also same as to your 28 number sum. Integration 0 to 45 sin x cos x upon value is a 9 plus 16 sin 2x. Same I asking about that thing to which derivative is this? Yes students, which derivative is this? So minus cos and cos derivative sin. So here I take suggestion. Suppose minus cos plus sin t, because this derivative is that. Now differentiation with respect to x. So sin x plus cos x dx dt. Upper way ready. Limit change. If you limit change, if x tends to 0, then t tends to here apply minus cos 0 plus sin 0. Sin 0 0 but cos 0 1. T equal to minus 1. Same operating students here. Limit change. If x tends to pi by 4, then t tends to minus cos pi by 4 plus sin pi by 4. Now what is the cos 45? 1 by root 2. So minus 1 by root 2 plus 1 by root 2. Yes, it convert to 0. Students, all data ready, only exemption of sin 2x. What to do for sin 2x? Here, making square on both sides, then you can cover sin 2x value. So start one by one. I just operate that in the making square, and after that derive the integrations formula. So here I want to sin 2x. That's why here making the square. Yes students. So also I have to minus cos plus sin is equal to t. I just write down square. So it should be cos square x minus 2 sin cos sin square x, and that what? It is 1, and that is sin 2x. So 1 minus sin 2x t square. Correct. It is repeat question, students. Sin 2x is what? 1 minus t square. That value you attach in place of sine 2x. Now I start systematically solution. So my integrations, 0 limit, then minus 1, pi by 4, then 0, upper side your dt, and lower side 9 plus 16, 1 minus t square. Now easily done. Students, my solution is a minus 1 to 0 dt 9 16 t square. So indirectly you can cover 25 minus 16 t square. Now here you think about two formula, 3 without root, 3 with root. Yes, it is without root. So can we write down this one in the way of minus 1 to 0 dt, here 5 square, and that is the 4 t square. Students, first chance covered to coefficients, 1 by 2a log and limit attach minus 1 to 0. Yes, what is the a? A is a 5 and constant minus variable, here plus, here minus, 40 with the 5 minus 5. As you like 5 and 40 exchange, it is same. Now 1 by 40. Apply the upper limit in place of t, minus lower limit apply minus 1. So minus 4 plus 5, minus 4 minus 5. Now easily done. 1 by 40. Here log 5 by minus 5, indirectly minus 1. But in modulus, it means log 1, 0. And here students, log of 1 by minus 9. So 1 by 40, it is 0. And here minus log 1 by 9 in the modulus. Actually, this negative value I cover in modulus positive, this minus cover upside. So 1 by 40 log 1 by 9 the minus 1 power, 1 by 40 log 9 to the base e. And here students, easily your 30 question also done. Now continue, I going ahead. Next question, 31. So continue, 31 question. Integration 0 to 90 sine 2x with the tan inverse sine x dx. Yes students, this also you tick mark in the way of IMP list. Yes, sine 2x tan inverse sine x dx. First of all, I just suggest in the terms of composite function sine x dx is the, and here students think out to sine x cos x, because sine derivative is covered to cos x. So I first write down 0 to 1 pi by 2 sine x. This cos I write the last, and other same tan inverse sine x. Students, this derivative actually is a sine. That's why I will separate. Now suppose sine x is the cos x dx, and change the limits. Limit 0 to pi by 2. So if x tends to 0, then t tends to sine 0, sine 0 0. If x tends to pi by 2, t tends to sine pi by 2, and sine 90 students, how much? 1. So you have to 0 to 1 limit change, here 2 t, that is the tan inverse t, and this one dt. Now apply LIT. This consider your algebraic, this inverse by LIT. I prefer my solutions and I get the easily answer, students. So LIT wise, I start my small journey. So integration I 0 to 1. First preference LIA, algebraic first. Sorry, inverse first. Tan inverse T first. And 2t dt after that. So first, second integration minus in the first derivative and second integration. You easily create your limit 0 to 1, 0 to 1. Students, this 0 to 1 for both function, it is variable t. Yes, so tan inverse t same. Here 2 t square by 2, 0 to 1. The whole function, not only this 2 to cancel. Here 0 to 1, 1 by 1 plus t square, that is 2 t square by 2, and limit 2 to cancel. So here apply your limit 1, tan inverse 1 45, 1 square, but 0 putting then tan inverse 0 0, here also 0. Now continue t square plus 1. So what to do here for further solutions? Yes, plus 1 minus 1 and make two separations. So you have to pi by 4. Here 1 minus 1 by t square plus 1 dt. So my answer is, students, here integration t plus tan inverse t 0 to 1. And now start your integrations. Pi by 4 same, 1 minus 0, and here, students, pi by 4 minus 0, because tan 1 man 45 degree. So your answer is finally pi by 4, this one minus 1 plus pi by 4, and finally covered to your answer 90 minus 1. And that is, students, I just checked my answers. Yes, 90 minus 1 is truly correct, 31. But these integer functions related composite, I assumption t. Now moving ahead, 32. So 32 also same doing. This also IMP sum. Integration 0 to pi x tan x by sec x plus tan x dx. Students, I think so first prefer anyhow converting into basic sine by cos. It's simple way you going sine by cos, that also sine by cos. After that you easily cover your data, because LCM cancel. I have only 0 to pi x sin x, 1 plus sin x. Students, here this repeat question already I explained 7.11, question number 12, this one. First of all, replace upper limit plus lower limit minus x for x, because I want to this x is removed. If you this x remove, then very easy solution. So I going to add replacing. So I 0 to pi minus x, sine also pi minus x, 1 plus sine pi minus x dx. Now which quadrant is this? Sine minus pi, yes, quadrant second. So pi minus x as it is, sine x, and and 1 plus sin x. Statement 2. And 1 and 2, anyhow, you make the addition. Yes, students, you make the additions. Sure, you get finally answers. So, if you both added, then denominator and this LCM same. So 1 plus 2 we adding twice side, and that is a 0 to pi x sin x plus pi minus x sin x upon 1 plus sin x dx. Students, as it is. Now you can take further solutions and create your in the answer wise. So students, I want in easily solution 2i 0 to pi x sin x pi sin x minus x sin x upon 1 plus sin x. Now this cancel and pi and this 2 divided, so I equal to pi by 2, 0 to pi. Now look at that, students, one more time I explain why this process is doing here. This x is removing in the way of upper limit plus lower limit minus x. Now very easy, you can start the conjugate terms and easily create your answer. Pi by 2, this pi and this 2 are divided pi by 2, sin x conjugate taking 1 minus sin x, other same. So you have to pi by 2, 0 to pi, that multiply sin square, and that is cos square. Now students, these are just divided individually. So your solution is must be, I get pi by 2, 0 to pi same running. But if you this divided 10, yes, 10 into sec x, and that is 10 square x dx. Now I go to my solutions. So pi by 2 same running, here tan x into sec x, but what kind of value for 10 square x? Yes, 1 plus 10 square sec square, so it is your sec square x minus 1 and 0 to pi same. Now I can get my integrations. Yes students, it is integration for sec x, tan x, the 1 is x. Now start your solutions. Upper limit minus lower limit. Sec pi minus 1, tan pi 0 pi minus. Now lower limit. Sec 0 1, tan 0 0, and here also 0. So pi by 2 minus 1 minus pi minus 1. So pi by 2 pi minus and minus 2. So this answer is students minus 1 and minus pi, and here students your answer going to sec pi minus 1, here pi sec 0 1 and minus 0 1. Yes students. Yes students, here one little mistake, my minus minus, here plus. So here limit is plus pi, here plus 0, it is plus pi, it is plus pi. Means your answer is pi by 2 pi minus 2. Yes, I make the correction first, minus and minus plus here, and one integration is x. Now here students this over sum. Now I go to 33. One by one explain about that 33 numericals. Yes, 33 is a very biggest numerical. Question 33. Integration 1 to 4 in modulus x minus 1, in modulus x minus 2, and in modulus x minus 3 dx. It is also very most IMP numerical. X minus 1, X minus 2 and X minus 3, 1 to 4. Students, first of all you dissolve in the partitions. First modulus X minus 1, second modulus X minus 2, and third also modulus X minus 3. Limit 1 to 4 cover, 1 to 4 cover and 1 to 4 cover. Now here start one by one journey. It is called your I1, I2 and I3. Yes students, I start only for regarding I1. I1 first explain, same as to I2 and same as to I3. So in I1, 1 to 4, students, you can take on the limits 1 to 4 and this equal to 0, definitely x equal to 1, then no partition, 1 less than x less than 4. I just create minus 1, 0, 3. So my modulus value is purely positive. Yes, and that is you getting I1 successfully. Finally, there are 3 numericals combine asking in these questions. So I slowly explain about that. First I1. So what is the I1? Without modulus, it is positive case, 1 to 4, x minus 1 dx, square by 2, 1 to 4. So 16 by 2 minus 4, 1 by 2 minus 1. It is 8, 4, and here minus half. It is 4 plus half. It is 5 by 2. First done. Oh, sorry, not 5 by 2. 4 to the 8 plus 1. Sorry, yeah, 9 by 2. Now, students, I2. What is your I2? 1 to 4. And x minus 2 dx. Here also go to 1 to 4 between 2 because this equal to 0. And x minus 2 equal to 0. It is common to between 2. And that are first partition. This is second partition. So 1 less than x less than 2, 2 less than x less than 4. I want to x minus 2. So students, subtract it 2 to each data. So you have to minus 1, here 0, here 2. In short, that case is purely negative and that case is purely positive. This part negative, this part positive. Now I start I2. So I2 here minus 1 to 2, x minus 2 dx, this one. And that also 2 to 4, x minus 2 dx, students. That 2 to 4, x minus 2 dx. Now start your solutions. So my answer is x square by 2, that is 2x, 1 to 2. Similarly, x square by 2, 2x, 2 to 4. And start here limit putting. Students, if you 2 putting, then 4 by 2, minus 4. Now numerical easy, but very lengthy. Minus half, minus 2. Same here, 16 by 2, 4 to the 8, minus 2 square 4 by 2, minus 2 to the 4. So your data is simple coming here 2, minus 2, 1 minus 4, yes, minus 3. Again, 1 minus 4, how much? 1 minus 4, minus 3, minus 3 by 2. And same as here, 8 minus 8, 0. And that is 2. 2 minus 4, minus 2. So indirectly you can cover here 2 minus 3 by 2, 3 minus, then minus. It is plus 2. So 4 minus 3 by 2, 8 minus 3 by 2, which is 5 by 2. Statement 2 done. Yes, 8 minus 3. Now I go to I3. Yes. And after that, I1, I2, I3 fully added, then you get the answer, students. So now I start our I3 1 to 4 modulus x minus 3. Yes, I3 what given 1 to 4 x minus 3 dx. So now here also students create your boundary between 1 to 4, that is 3. One is 1 to 3, other is 3 to 4. Correct, no? Yes, 1 to 3 and 3 to 4, because x minus 3 equal to 0, then x equal to 3. So one case 1 less than x less than 3, 3 less than x less than 4, and I want to x minus 2. So here, sorry, x minus 3, x minus 3 getting here also 3 minus 3, finally minus 3 minus 3, here minus 2 0. Purely students it is negative case, and here 0 to 1 it is purely positive case, and that solution is must be start now. I3 your 1 to 3, and second your 3 to 4, and create your solution systematically. So integration I x cube by 3, sorry, square by 2, 3x. Next, x square by 2, 3x, but 3 to 4. It is 1 to 3. Now wait to answer. I3 9 by 2, 3 3s are 9. Minus carry outside students. Now one chance, half minus 3. Here 4 square 16 by 2, minus 4 3s are 12. 3 putting 9 by 2, but 3 3s are 9. And here get to systematically answer students. So I3 I have to 9 minus 18 minus 9 by 2. Here 1 minus 6 minus 5 by 2. Okay, same as that 2 8s are 16, so 8 minus 12 minus 4, and 9 minus 18 which is minus 9 by 2. So here you create easily simplify to your value I3. So now I1 is ready. This is my I1, yes, I1 is a half, so I calculate I3 is a further. What is the I3? My plus 9 by 2 minus 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 means minus 5 by 2. Next minus 4 and minus minus plus 9 by 2. So you getting finally LCM 2 overall. So 9 minus 5, 4 to the 8 and 9. 9 and 9 18, and here 8 and 5 13 by 2. It is 5 by 2. Yes, it is your third equation. First equation, second and third. So finally you can do I1, I2, I3. What is your I1? 9 by 2. I2 is that 5 by 2. I3 is that 5 by 2. So 9, 5 and 5, 10, 29 by 2. Yes, not 29, 19. Yes, 5 and 5, 10, 10 and 9, 19. 19 by 2 is your final answer students here, easily and happily done. Now calculate next numerical. Continue in the way of your 34 sum. Yes, now coming to start prove that numericals. Yes, 34. Integration 1 to 3 dx x square with x plus 1, and you prove that 2/3 plus log 2/3. That's your given to prove. Means very easy. Here I think you're thinking partial fraction method, students, because x square and x plus 1, correct? But I can do here shortcutly. Check here. 1, 2, 3 dx by shortcut available, don't worry, look at that. X plus 1 factor, I write down x plus 1 and minus x. You can easily create your by fractions, this upon this and this upon this. So 1, 2, 3, this upon this, 1 by x square. But secondly, x below x square with the x plus 1, that cancel. This answer ready. And here again can do shortcutly. So integration I 1 to 3, it should be x raised to minus 2 dx. And here pending are x with x plus 1, 2, 1 to 3. So x raised to minus 1 by minus 1, limit 1 to 3. Because x raised to n plus 1 by n plus 1. And here again by parts, shortcutly, x plus 1 minus x. Students, that here 1 to 3. So this upon this upon this, both separations. It should be minus 1 by x, 1 to 3. And here integration of 1 upon x minus 1 upon x plus 1 dx. Limit same 1 to 3. Yes, it is 1 to 3 here I written, don't worry. So integration I here 1/3 minus 1 by 1, and that log modulus x minus log modulus x plus 1, and 1 to 3 limit as well as, students, I put there. So now putting your limits and get the easily and happily answer. So you have to I, what is the 1 minus 3? Minus 2/3, and here log of x by x plus 1, and my limit 1 to 3. So you can get 2/3. Apply the upper limit, yes, which is 3 by 4, but 1 apply then 1 by 2. It is also conversion in the way of prove that 2/3 minus log 3 by 4 divided 1 by 2. Students, I want to this answer. 2/3 coming, minus not coming here, plus, don't worry, this also coming then. 2/3 log 3 by 4, 2 by 1. That cancel, 2 ones are 2 twos are. So can I write down this minus or upper way? Because I want to plus, so log of here 2 by 3 raised to minus 1, and this minus 1 carry forward outside, it is plus log 2/3. This minus carry forward outside, and here, students, your final proofing 2/3 plus log 2 by 3 base e. And now, students, here our up to 34, and this part, students, I stop here, and further explanations in the exercise definite integration last part remaining, students, last part remaining. After that, some numericals in exercise 7 and miscellaneous exercise 7 related I going to in the next part. Okay, students, bye bye.